and our addition theorem was like this. Probability of A union B, that is union. Union also signifies or. So whenever or this event happens or this event happens, you have to use the sign union and it signifies addition. So that is why it is known as addition theorem. Probability of A union probability of B. So the probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. This intersection represents and, or it also represents multiplication. Fine. So whenever multiplication comes or you have and, then at that time you have to use intersection sign. Now this probability, that is addition theorem, is applicable only for non-mutually exclusive events, that is those events which can occur both at the same time, that is heads and tails cannot happen at the same time. So that is why we have these are mutually exclusive events. Non-mutually exclusive events are like in a previous problem we had discussed an example of India winning a match, Australia winning a match. These are mutually exclusive events. Suppose in India versus Australia match. But when it comes to a thing like rain happening in a test match and India winning the test match, both of these things can happen at the same time. So it can rain also during a test match and India can win also. So these are non-mutually exclusive events. Both the things can happen at the same time. For example, registration number 1 can pass in the examination, registration number 2 can also pass in the examination. Both events, that is event A, registration number 1 passing in an examination and registration number 2 passing in the examination, are non-mutually exclusive events. So taking the concept forward, we have our next things, that is problem number 14 we are solving now. So the problem number 14 is like this. Okay, a card is drawn from a pack of 52 playing cards. What is the probability that it is a club or a king? See, this sign, I've said that it is clover. It is more popularly known as club also. Okay, club. So what is the probability that it is a club or a king? So let us see. What is the event they are asked? What is the probability that it is a club or a king? So that means there are two different events. It can be a club, one event, or it can be a king, right? The second event. So let's split. Event A, it is a club. Event B, it is a king. So what we are doing is first we have to see what they have asked. The question that they have asked is, what is the probability that it is a club or a king? Club or a king. Okay, so when they have asked what is the probability that it is a club or a king, we are splitting this into two events, event A and event B. Event A is it is a club, event B is it is a king. So event A, it is a club. What is the probability that it is a club? Probability of A is equals to, there are total 13 clubs, 13 in the set, divided by total number of cards in the deck is 52. So 13 divided by 52, which is equals to 1 upon 4 equal to 0.25. This type of problems we have done earlier. If you have difficulties, you can contact me or check the earlier problems. 2 mark problems we have solved earlier. Then event B, it is a king. Now probability of B is equals to, there are total 4 kings in the deck. So 4 divided by total number of cards in the deck is 52. So 4 divided by 52 is 1 upon 13. That is nothing but 0.08. Now I know now the probability of A. I know the probability of B. What they have asked, what is the probability that it is a club? That is, what is the probability that event A happens or event B? Or means addition theorem you have to apply. So probability of A or B they are asking. So probability that it is a club or a king is given by probability of A union B, which is equals to probability of A plus probability of B minus probability of A intersection B. So this entire formula is there. Why this is there is because non-mutually exclusive events are there. Non-mutually exclusive events means there are possibilities that it can be a club also and king also. For example, it can be a club, king of clubs. This way it can be, right? So that is why, because both the events can occur at the same time, that is why we have this part also, minus probability of A intersection B. Okay, so we have written the formula, just substitute probability of A, we have found out it is 0.25, probability of B 0.08, okay, minus probability of A intersection B. Intersection B is given as multiplication, so 0.25 into 0.8, right? If you solve this, first multiply. Always remember, first you have to multiply. You have to use the BODMAS rule. If you know BODMAS, this stands for bracket, this stands for offs or offsets, this is division, multiplication, addition, subtraction. So remember, always first you have to go solve brackets, then you have to solve offs, then you have to solve divisions, then multiplications, then additions, and then subtractions. Based upon that, if you in this equation, first you have to multiply. Okay, bracket, if it is there, anything within the bracket you have to solve. So then you have to multiply. Multiplying this and this, you will get 0.02. okay, and then you have to add and then you have to subtract. So adding and subtracting, you will get probability of A union B is equals to 0.31. okay, this is the conventional way of doing a problem. You will get full marks if you do this. Generally this type of problems are asked in the examination, but there is an alternate way of doing this. Okay, this problem can also be solved without using the addition theorem if you want. So how can this be solved? Let's see. Sample space, we know n of s is equals to 52. Fine, n of s is equal to 52 because 52 playing cards are there. Fine. Now event C, suppose if it is there, the card is a club or a king. That is what they have asked. What is the probability that it is a club or a king? So how many clubs you have? 13 clubs you have, okay, which includes the king of club, right? It includes the king of club, this one, it is included in this 13, right? Plus there are 3 other kings, because see, card is a club, total 13 clubs we have, right? And or it is a king, so there are 3 other kings of diamond, then we have of spade, and we have of heart. So these 3 kings we have. One king is already included in this 13. So 13 plus 3 is equals to 16. So total number of cards which are either club or king is 16. So that is why probability of C is equals to n of C upon n of S, which is equals to 16 upon 52, which is equals to 0.308. Fine. So this is how you have to solve. Without using addition theorem also you can solve, and you will get the same answer. This is 0.31, that is 0.310, and this is 0.308. So nearly the same answer. So you can use this also method, this also method. Preferably go for this method, because addition theorem carries 5 marks, they have said in your syllabus. So probably whenever they ask you questions regarding this, it is addition theorem itself. Okay, let's move to the next question. The question is like this. Question number 15. In a city, 15% okay, of the people read newspaper A, 13% of the people read newspaper B, 8% of the people read both newspapers. Okay, considering only 2 newspapers circulate in the city, find the probability that a person selected, Okay, this is not visible. Find the probability that a person selected at random shall read either newspaper A or newspaper B. So what they have asked here is, there are two newspapers and only two newspapers are there circulated in the city, A and B. Now, out of this, if we see how many people read newspaper A, they have said that it is 15%. So, the total number of people who read newspaper A is 15%. The total number of people who read newspaper B is 13%. Fine. So clearly, probability of this, if we convert this percentage into fraction, is 15 upon 100, which is nothing but 0.15, and this becomes 13 upon 100, which is equals to 0.13. So that is what I have written here down. So probability that a person selected at random reads newspaper A is 15%, which is equals to 15 upon 100, which is nothing but 0.15. And probability of a person selected at random reads newspaper B is 13%, which is equal to 13 upon 100, which is equals to 0.13. So I know what they had asked here is, find the probability that a person selected at random shall read either newspaper A or newspaper B. That means a person selected at random can read newspaper A, he can read newspaper B, or he can read both the newspapers. So or is there, that means we have to add, and there are two events, that is a person selected at random reads newspaper A, a person selected at random reads newspaper B. So that is what I found out, and I found the respective probabilities also. Probability of A is 0.15, probability of B is 0.13. So probability of A union B, that is probability of A or B happening, is given by probability of A plus probability of B minus probability of A intersection B, because he can read both the newspapers also at the same time. So it is given by 0.15 plus 0.13. We have found out 0.15 and 0.13. Okay, minus 0.15 into 0.13. This means into, I have told you. So 0.15 into 0.13. Okay, so 0.15 plus 0.13 minus this much. If you multiply, you will get this, and when you add up everything, you will get probability of A union B is equals to 0.2605. So that means the probability that a person selected at random shall read either newspaper A or newspaper B is given by 0.2605. Fine. Let's take the next problem. Now this is a big problem. From here onwards, what I've taken is, I've mixed simple problems also as well as little difficult problems also. So what you are supposed to do is, if suppose I'll just mark and send you certain questions or subsections of these problems. Like for example, in this question I have A, B, C, D, E. So 5 different scenarios or conditions. Out of this, you will get either 1, or at the maximum you will get only 2 in the examination. So generally so far you have got only 1 condition. So that also is this condition A. Okay, generally this kind of conditions are asked in the examination. So far only this type of conditions were asked. Suppose if they ask other conditions also, that is why I have taken this. So if you find that the other conditions are difficult, you can concentrate only on this, and others, if you are feeling that this is easy for you and you are understanding this and you don't want to lose even 1 mark in QT, then you can go for other B, C, D and E also. Okay, let us start this. Both husband and wife apply for a job in a company. Okay, both are applying for a job. So what happens is the husband might be selected, the wife also can be selected, both can be also be selected. So it is a non-mutually exclusive events, both can happen at the same time. So in this case, just I'll go through this problem. Both husband and wife apply for a job in a company. The probability that the husband is selected is 5 upon 12, and the probability that wife is selected is 3 upon 4. If the selections are non-mutually exclusive, they are directly given. What is the probability that either of them is selected? So any one of them is selected or both are selected. None of them is selected. Only wife is selected. Only husband is selected. Both of them are selected. Okay, so first we'll split them into two sections, that is two events. Event A, husband is selected. Event B, wife is selected. And let us see how this works. Here it is. So event A, husband is selected. Event B, wife is selected. Event A can happen with a probability of 5 upon 12. How 5 upon 12, from where I have taken? This is given in the problem. Probability of selection that the husband is selected is 5 upon 12. So probability that the husband is selected is event A, and that is why probability of A is 5 upon 12. If you divide, you will get 0.417. Then probability event B is wife is selected. What is the probability of event B happening? Here they have given. Probability that the wife is selected is 3 upon 4. So probability that wife is selected, P of B, is 0.75. Okay, so now that we have divided these two events separately, let us see either of them is selected. Any one of them is selected. So if this is the case, it is a case of addition theorem. So probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. So which is equal to probability of A is given or we have found out 0.417 plus probability of B is 0.75 minus probability of A into B. So 0.417 into 0.75. So that is this. So probability of A union B is equals to 0.854. Okay, if you add up this. So this is section A. Section A is done. The second question that they have asked is none of them is selected. Okay, B, none of them is selected. So the question none of them is selected. See here, suppose if X is the event that denotes none of them is selected. Okay, X is the event that denotes none of them is selected. So probability of X is equals to probability of A union B and its complement, that is none of them is selected. That means A is not selected, B is not selected, both are not selected, and that is negative of this. So 1 minus probability of A union B, it comes complement. We have seen what is a complement event. Suppose probability of A is there, so this is probability of or chances of event A happening. Then what is the probability that event A will not happen? That is given by probability of A bar or A dash, which is equals to 1 minus probability of A. So probability of A bar is equals to 1 minus probability of A. Now what happens in this case is none of them is selected. Probability of X. So probability of X is nothing but probability of A union B not happening. Not happening is given by bar, which is equals to 1 minus probability of A union B. So which is equals to 1 minus 0.854, which is equals to 0.146. Fine. So here I have explained you with a diagram Suppose this is the universe, that is the rectangle, and we have two circles, that is A and B, representing two sets, and they are intersecting. This shaded region is nothing but probability of A intersection B. So probability of A intersection B is represented by the shaded region. This region which is there, I am shading it up, see here. Only this region which is there, which I have shaded now, that is this part, like the moon, crescent. Okay. Now this part which is there, this is only A happening, that is only husband is selected. This dotted part which I am putting here, it means only B is happening. What is B? B means wife is selected here. So only wife is being selected, is shown by dots. This shaded region which is there, which includes husband is selected, wife is also selected, that means both are selected. And both this part which is there, that means only husband is selected, only wife is selected, both are selected. These three cases it covers, that is this part, see. Okay, A, B, it includes both part, this, fine. So this include this part which is there, this means A or B, that is the addition theorem will give you this part. Now the remaining part which is there, apart from this shaded region which I am shading now, this represents both are not selected, right? Neither A nor B. So that is what I want to find. So if one is the area of the entire circle or of the entire rectangle, the shaded region will be 1 minus this, and I know that this is A union B, right? A or B, addition theorem. So probability of A union B, it comes, and that is how my problem this I have solved. So probability of X is given by probability of A or B not happening, that is A union B not happening, complementary of A union B. So which is equals to 1 minus probability of A union B, which is equals to 1 minus probability of A union B is 0.854, which is equals to 0.146. Now event C says that only wife is selected. Now only wife is selected is given by this part. I have a diagram drawn here already. I'll show you this part. See here, this is husband being selected, this is wife being selected. This entire region, that A, husband is selected, wife may be selected, may not be selected, that is a different question. Husband is selected here, okay. A, what does this circle represent? That is this circle. If I remove it out, it means wife is selected, husband may be selected, husband may not be selected, that is a different issue. Coming to this, like a moon, crescent, so it means only A, that is only husband is selected, wife is not selected, that is a question. This wife is not selected, husband only is selected. This means wife only is selected. See here, if you see this, wife only is selected, fine, only wife is selected, husband is not selected. Now this means both are selected. You can see this, the middle portion which is shaded. So both are selected, both A and B, okay. And this shows the intersection of A and B. And this A or B, that is addition theorem will give you this, that is A is selected as well as, or maybe B is selected, or maybe both are selected, A or B. And neither A or nor B is this shaded region which I am shading now, okay, with lines, striped region. This is the striped region. remember, not the earlier one. So whatever the white striped I have given, that represents neither A nor B. So how can you find this? Entire region, if it is 1 minus this. Fine. So this is how I'm solving this. Now the third question comes like this. Only wife is selected. Only wife is selected. Probability of C is equals to only wife is selected. See, only wife is selected means this represents wife is selected. Both are selected. So from wife is selected, that is probability of B. If you reduce, both are selected. That means intersection. If you remove intersection of A and B, you will get only wife is selected. Right? So in this case, probability of C is equals to probability of B minus probability of A intersection B. Right? So which is equals to 0.75 minus 0.313, which is equals to probability of C is equals to 0.437. So this is how you have to solve this thing. Now this is a difficult part. If you want, you can drop also, right? So next one I'm giving you as a homework, D, that is only husband is selected. Here only wife was selected. Here only husband is selected. Similar to this problem, you have to solve this. Solve this in your fair book. Okay, not in your assignment book. Solve it in your fair book. After this only you have to solve this. Let's take the next problem. E. Now what is E? Now E, if you see, both of them are selected. That is AND comes. A, that is wife is selected and B is selected at the same time. So A and B. So probability of E, suppose, is both of them are selected. That is both husband and wife are selected. So probability of E is given by probability of A intersection B, which is equals to probability of A into probability of B, which is equals to 0.417 into 0.75, which is equals to 0.313. Now next problem we'll take 17th one. This is also a standard problem which has been asked many times in an examination, but only this is asked or this is asked generally. Okay, but if they may ask you other one also, you should be in a position to do it, but generally so far they have asked only these two cases, A and E. So let us take this problem. There are two students, A and B. They try to solve a problem independently. The probability that student A will solve the problem is 3 by 8 and the student B will solve the problem is 1 upon 2. What is the probability that A, the problem is solved, B, both of them solve the problem, C, B solves the problem, D, only B solves the problem, E, none of them solve the problem. Let event A be, there are two events. See here, student A solves the problem, student B solves the problem. So event A, let it be equal to student A solves the problem, event B, student B solves the problem. Now therefore probability of A they have given directly, it is nothing but student A solves the problem is 3 upon 8 and student B solves the problem is 1 upon 2. So probability of A is given as 3 upon 8, which is equals to 0.375, and probability of B is equals to 1 upon 2, that is equal to 0.5. The